let's start working on script 4a. This is what we have done so far. We started with this, our goal was to do a 4-class classification for a river basin. So we selected a basin, we have a Sentinel-2 dataset, we mask clouds and shadows. So one of the things that you should always start doing now is, as soon as you apply our filters, map a cloud masking function that removes all the pixels that are determined to be cloudy or are probably cloudy, and mask them. So they won't be used when you compute the median composite. You do a composite, you add the indices. You should add indices that are representative of each of your class. So again, we are using 4 indices, one kind of each for one of the classes of that we are targeting. And there are many indices, so you can select the one that works best for detecting the features of that particular class. You can add other variables. Here we are adding elevation and slope. You can add any other variables that might be relevant to your classification. Once you have your final composite, you need to normalize the composite. That means you need to make sure that the pixel values are between 0 and 1. So we take the min and max of each band and scale each band so that all the values have the same relative scale, but the absolute values are between 0 and 1. Once we have that, we can split our training data into 2 fractions, train a model on the training data set. Once you have the model, classify the image, and then you check the data against the validation GCPs and you compute the accuracy. And finally, we compute our confusion matrix and we compute the accuracy. So this one, it's a pretty good result. We got our confusion matrix and we got almost 95% accuracy. So we got pretty good result. We have our final composite that is available to us. Now, when you kind of try to scale this to a large region or you have a lot of training data, many times when you're running this code like this, you will see this error here, computation timed out. As you start using Earth Engine, you'll start seeing this more and more. That when you have computation that exceeds a certain time threshold, Earth Engine will display this error. Computation timed out, user memory limit exceeded, and so on. These errors are there because in this environment, when you are in the code editor and you are interactively computing something, Earth Engine puts a time limit of 5 minutes. That means when I run this script, if this confusion matrix or accuracy or whatever I'm trying to display, this classified result cannot be computed in 5 minutes, it will time out. It'll display these errors in computation timed out. This means that you cannot do this computation interactively. It doesn't mean you cannot do this in Earth Engine. It just means you cannot do this interactively. To overcome this error, a simple fix is you need to export your result. When you run an export, you use a different type of computation. When you run export, you're using the batch computation. In the batch computation mode, you have access to a lot more machines. You have a lot more RAM that is available, and you just have more resources. Plus, that computation can run for as long as it needs. You will not get computation timed out errors when you export. So one of the things you need to learn is how to export your classification result. So let's see how we can do that, that we're going to cover in this script now. So one of the things you may want to export is export classified image. So we have our classified image that we have loaded onto the map here. Many times when you're working with large classifications, if you're trying to classify an entire country or entire state, there's simply no way it's going to finish and display the results in 5 minutes. So when you try to display this on the map, we'll say, map tile error, Earth Engine capacity exceeded, computation timed out. If you see all those errors, that simply means that you need to switch your mode to a batch mode by exporting the result. So we have this image, classified image. Let's just export that. So we'll say export image. We have 3 options. We can export it to an asset. This is helpful where you say, I want to keep the asset in Earth Engine. I want to see my results in Earth Engine. I cannot see it in real time, but I can export to an asset. And once the asset is exported, I can load it and visualize this, or I can use it in my other script. Export to cloud storage is useful. Many times, if you want to take this classified image, do some post-processing using some deep learning techniques or using other Python libraries, and you're using Google Cloud, you may want to take this and store it into Google Cloud. Let's see first how we can export it to Google Drive, which is you have the classified image, you want to download it. Maybe you are more comfortable computing statistics or creating your maps in QGIS or R or Python. So you want to download the result. So let's fill the parameters for this. Let's say let's export this image, classified image. We'll use the Earth Engine folder for it to export. Always specify the region. Whenever you're writing an export function to Drive, always you need to specify your region parameter. We'll use the geometry of the region for doing this. Scale 10 meters. Whatever scale you specify, that scale will be used for running your classification. So make sure you use the native scale here. For any large classification, you have to set this pixels to a high number. I set it to 1:10. You generally have no problem. And then rest we can skip. And once you have this function, let's run it. And we export this image. One of the things that will happen is once you have exporting this, and if you have pixels that are outside this region, which are masked, you'll get this black pixels. This is typical when you export something, a classified image as a GeoTIFF file. Earth Engine says, oh, I have only values 0, 1, 2, 3. I'll export this as a byte image where the values are between 0 to 255. And that data type doesn't have any way to store null values or no data values. So if you are exporting something classified image like this, and if you want to retain the no data mask, we'll just convert it to float. And we can start the export. Once you run this export, the whole classification workflow will run. It can run for as long as it needs to be. I ran this before the class, and you can see it took me about 10 minutes to run this export. For a large region, it might take 1 hour, 2 hours. It might even take 2 days if you're running a very complex workflow. But it will keep running. It will not give you computation timed out error. Once it finishes, you'll have your GeoTIFF file. Let me show you what the file looks like in QGIS. I've already exported this, and when you load it into QGIS, this is what you get. You can see now I have a GeoTIFF file, which is classified into one of the 4 classes. Let me identify the pixel here, and you can see this is band value 3, band value 2, and so on. Right. So now I have a classified image with the pixel values that were computed using Earth Engine, and I have those on my computer. Questions? Question on toFloat. If you see, the values outside of this valid range are NaN values. To store a NaN value, you cannot store them in a data type called byte. So when you are storing something on as a GeoTIFF file, you have to specify what is the data type of your values. You can store them as integers. You can store them as floating point numbers. You can say, how big is my integer? Because each pixel will have to hold that much of values. So if you say, I will store maximum 8 byte in one pixel, and it'll reserve only that much space. So you can only store, if it's a 8-byte, 8-bit pixel, a byte, single byte can hold only values if the values are between 0 and 255. Anything else it cannot store. So when you export something to from Earth Engine and your values are like 0, 1, 2, 3 or less than 255, Earth Engine will say, oh, I'll just use the byte as my data type as a default. And if you do this, there's no way to store NaN. There's no way to store any other values except 0, 1, 2, 3 up to 255. So it'll assign value 0 to your no data pixels. If that's fine, you can go ahead with that. It'll take less data storage space. But if you want to keep those masked pixels and assign no data value, you convert to float. A floating point can store all larger range of values, including a value called NaN, which is a no data type. So we were able to export our image. Now, sometimes when you are trying to print your confusion matrix for accuracy, your confusion matrix will time out. So you say, I'm trying to get the accuracy of my model and it just timing out. So how do I export my confusion matrix or the accuracy number? Many times for large classification, if you run this and say, print me the accuracy of this using my validation data, and it times out. You can't even see that number. So how do we export that? Now we know from our work with the export function that Earth Engine allows to export an image, a table, a video, or a classifier. But it doesn't allow us to export a confusion matrix or a number. So accuracy is just number. How do I export a number using Earth Engine? There is no built-in function to do this. So when you are faced with the situation where the data type that you want to export is not an image or not a feature collection, the workaround is to convert your objects into feature collections. What's a feature collection? A feature collection is just a list of features. What's a feature? A feature in Earth Engine is defined as something with a geometry and some properties. Okay? So if you can create a feature collection with some features, with some geometries and properties, which contain your data that you want to export, then you'll be able to export that. Now, let's say I want to export this thing called accuracy. So I have this, my confusion matrix accuracy, and I have this number. So I have this variable called accuracy, which stores the value of my model's accuracy. I want to export this number. So let's see how can we take this number and convert it to a feature collection. So I'll create a variable, we'll create a feature collection. Now, as we saw, feature collection is nothing but a list of features. So we'll give it a list of features. So right now I've created an empty feature collection with one empty feature. We can fill up the feature. A feature is a geometry and some properties. Now, what is the geometry for this case? There's nothing, right? It's just a number. We don't have a geometry. So we can give a null geometry. Property is just a dictionary, key value pairs of all the stuff that we want to store in this feature collection. So we can create a dictionary and say, I want to have one key called accuracy with the value accuracy. So now I've created a feature collection with one feature with null geometry and a property called accuracy with the result of my accuracy assessment. Let me print this and show you that we really have a feature collection here. And this feature collection is having one feature with null geometry and one property called accuracy with the value that we want to export. So once you have this, you don't need to print it, because if you print it, it'll also time out if it's a very large computation. But now you have a feature collection that we can export. So let's export this. We can say export table to drive. And let's put the parameter. Since we have a feature collection now, we can now take this and export that. File format, you can export it as a CSV file. And now when I run this, my export will run. If the computation required to compute this accuracy might takes 15 minutes, 1 hour, it'll still run that export, and I'll get my CSV file with accuracy. We can take it one step further and say, I want to have one more property with my matrix, my confusion matrix. And this is my confusion matrix. I want to export that as well. To export this, we can convert it to text. So this confusion matrix is an object. Remember, we run the accuracy assessment. We saw that this is an E object, and you can do a bunch of computation with it. If you want to just convert to a text object that you can export it, we can call dot array. So you can just call dot array. And now if you see the feature that we have, it'll have two properties. one with the accuracy, and one is a text representation of the confusion matrix. So you can see I have my matrix, which is the confusion matrix, and I have the accuracy. So we can start the accuracy export, and it'll give me a CSV file containing the resulting of the results. The reason we had to do this is if printing this is timing out, and it will happen as you start working on more complicated problems. So again, I did this a bit earlier today. Let me show you what the result looks like. So once the export finishes, you'll get a CSV file that looks like this. Just download this. So you get a CSV file containing two columns, one for each property, one containing the accuracy of the model, and another containing the confusion matrix. This is also helpful where you're writing a paper or making a presentation. You just want your confusion matrix as a text. You can just export this and you will have that ready for you. So we learned how to use export to overcome any computation timed out errors. You can export stuff as images. You can, if you want to export number or a confusion matrix, just put them in a feature collection, and then you can export a feature collection. The last thing we have to learn is how to export your results as asset. This is one of the biggest thing that you should take away from this module is when you are working on a large project like this for classification, you need to break your script into intermediate chunks. So you do not do your full workflow in a single script because it will soon become quite large, quite unwieldy. So at intermediate steps, you should take your results, export that as an asset. So you say, I need to compute this composite. Let me write the code for it and then export this as an asset. So it'll go back into Earth Engine in your account, but it's pre-computed. So Earth Engine will say, I'll compute all the pixel values of the composite and put it back into Earth Engine. Then you import that asset and say, what's the next step? Oh, I need to extract the values. So you extract all the values and you have a feature collection. And say, okay, I have my feature collection, export that as an asset. So export that, the computation will run. And now you have a pre-computed feature collection that we imported. So in the third script, you'll say, get my composite, get my samples, and now I'll run the classification. Once I do the classification, I can also export my classification results. And again, in the last script, you say, I have all my results. Let me visualize this. Let me compute some statistics and so on. Doing so will allow you to work in modules. If you have problems with one part of the module, it won't affect the other one. The whole thing might take, if you run the script and say, I'll just export only the results, that might take 5 hours to do. And then you find out, oh, I made a mistake in the first part. If you do it in by module, you will finish your computation. And once you've done it correctly, you'll never have to run the computation again. So you'll save your time and your workflow will go much faster. So when you are going to export this as an asset, we can use the similar workflow, but I want to show you one more thing when you are working with classified data. So let me go to the user guide. When you are exporting stuff back into Earth Engine, you need to understand about image pyramids. Let's say we want to export this classified image to Earth Engine. So Earth Engine will write that image into Earth Engine and it'll ask you, how do you want to compute the pyramid? Now, let's understand what Earth Engine means by pyramid. Whenever a new image is ingested into Earth Engine will take that image and create low resolution versions of that asset. So at the bottom here, you see this is your original image. And Earth Engine stores that. So whenever you upload an image, a new satellite image has become available, Earth Engine loads it. The original version is saved. So when you export your image to Earth Engine, it'll say, I have my original version. Let's say this is a 10-meter resolution pixel. So you have all the pixels, which are 10-meter resolution. Remember when you load something in Earth Engine, it loads very fast. The reason it loads very fast is it's not displaying this full resolution version in your code editor because you zoomed out and you can't really see those pixels. Also, you are able to specify any scale in your computation and Earth Engine does that. The way it does that is that alongside your original resolution image, Earth Engine creates this low resolution versions of this. The way it does is it takes the 4 neighboring pixels and say, for this 4 pixels, let's create a larger pixel. And we'll create this another image, which is now a 20. So we have a 20-meter resolution image, which has got 4 times the fewer pixels. Each pixel is created by taking the average of 4 pixels and creating this. You keep going. This one is a 40-meter resolution pyramid. This one is 80, 160, and you keep going. You keep going till there's only 1 pixel left representing the whole image. And all of these images are pre-computed and stored alongside your image. Now, you say, display this image. It's a global scale 10-meter resolution image, and you're zoomed into your city. It says, I only need to display this tile at this resolution. It'll only fetch that pyramid and show that. And this allows Earth Engine to do this interactive computing for even very large images. So when you export into Earth Engine will say pyramiding policy. That means, how do I take your source image and compute this pyramid? The default pyramiding policy is mean, that is average. Take my 4 pixels, and when you create a pyramid version, take the average of those 4 pixels. That works fine for any raster data set such as temperature, satellite imagery, and elevation, and so on. But what if we have a classified image? Here is an example of a classified image. We have class 1, class 1, class 1, class 2. Now, when this is your pixel values, and Earth Engine needs to create this one larger pixel. And if you use the default pyramiding policy of mean, which is average, you'll get pixel value like 1.2. Now, this doesn't make sense, right? Or 1.3. A pixel value cannot have 1.3 because it's a classified image. It has to be either 1, 2, 3, 4. So in case of discrete images where your pixel values are integers, you do not want Earth Engine to create this mean value. So Earth Engine provides you with an option to specify another pyramiding policy. The one that is recommended for discrete rasters is something called mode, M-O-D-E. Mode is just the majority. So it says when you create a new pixel out of this 4 pixels, assign this the mode value. So in this case, the mode value will be 1. So out of 4, 3 pixels are 1. So my pyramid value will be 1. And again, this is mainly used for display purposes. When you are exporting it or computing statistics, you say, run my computation at the native resolution, it'll use this original image. So your statistics are not affected by any of this. But if you do not specify a mode policy, as you zoom in and out, your classes will flicker. Because again, you are doing this mean that classes do not exist. So a good value for pyramiding policy for image assets is mode. Now you might be thinking, what happens if there's a tie? What if there is a 1, 1, 2, 2? Like this pixel is 2. So what happens in case? And again, you read this page documentation, it says, in case of tie, it'll take the top left pixel value as the mode value. So this is how, this is what pyramiding policy means. And this is what you need to specify when you export something as an asset. All right, let's do the exercise where your task will be to export the classified image as an asset.